In this video, we're going to talk about operations with functions. More specifically, adding, subtracting, multiplying, and dividing functions. So adding functions, if I have f plus g of x, that is the same thing as f of x plus g of x. And its domain is going to be the intersection of the two functions' domain. Subtracting functions, f minus g of x is equal to f of x minus g of x, where again, the domain is going to be the intersection of the domain of the two functions. Multiplying and dividing functions are very similar. Now, I want to show a very, very quick example of how this works. So I'm going to come up with two very basic functions. I'm going to do f of x is equal to x plus 2. And I'm going to do g of x is equal to 2x. So if I do f plus g of x, that's the same thing as what? X plus 2 plus 2x. Just combine like terms, that's 3x plus 2. Now, if I use the other side, that's f of x plus g of x. Well, f of x is x plus 2. I'll do it in a different color for g of x. That's 2x. Really don't need the parentheses, but I'll use them here. And it's exactly the same thing, 3x plus 2. And I can do similar examples with subtraction, multiplication, division also. All right, so use the functions below to answer the questions. For questions A through D, we're also going to write the domain in interval notation. So let's start with f plus g of x. Again, I'm going to rewrite it using the notation above. That's the same thing as f of x plus g of x. Well, f of x is x squared plus 6x plus 8 plus, I'm going to do g of x in a different color, so that's going to be x squared minus 4. Well, a lot of this is just combining like terms. X squared plus x squared is 2x squared. 6x will just come along for the ride, and then 8 plus a negative 4 is a positive 4. So f plus g of x is equal to 2x squared plus 6x plus 4. Don't worry about taking out a greatest common factor. You don't have to factor it, just leave it. Okay, now let's write the domain. The domain of f plus g of x, well, that's the same thing as the domain of f of x intersecting domain of g of x. Well, f of x is a quadratic function. We already know its domain is negative infinity to positive infinity. Intersecting g of x, another quadratic function. Well, when we intersect two all real numbers, we're going to get all real numbers. So the domain of f plus g of x is all real numbers, meaning I can plug in any number I would like, and I will get a real number coming out. Okay, let's skip down to b then. So now that is g f of x. Now what that means is I'm going to take and multiply the two functions together. So I'm going to expand it out. That's the same thing as g of x times f of x. Well, you know g of x from above is x squared minus 4. And in blue, I'm going to do f of x, which is x squared plus 6x plus 8. So the rest of this problem, we're really just multiplying. So I'm going to distribute the x squared to that trinomial. So that's x to the 4th plus 6x cubed plus 8x squared. Now I will use a different color so that you can see. I'm going to do the same thing with negative 4. Negative 4x squared minus 24x and minus 32. The rest of this problem, we are just combining like terms. X to the 4th will come down, plus 6x cubed. 8x squared minus 4x squared is a positive 4x squared. And I'm going to bring down the remaining terms. what does that mean? Gf of x is equal to x to the fourth plus 6x cubed plus 4x squared minus 24x minus 32. All right, let's take a look at the domain then. Now, that's going to be the domain of G of x intersecting the domain of f of x. Well, we already did this in the previous problem. We know the domain for both is negative infinity to positive infinity, so I'll write it one more time just to show. If you don't need to write this intermediate step, you don't have to. So the domain, gf of x, is negative infinity to positive infinity. Again, no matter what real number I plug into this, I will always get a real number coming out. All right, so let's go to the next page then. Again, we're going to use the same functions from the previous page. Okay. Now, we're going to do a division problem. Well, that's the same thing as f of x divided by g of x. So again, we'll do f of x is x squared plus 6x plus 8. And on the bottom, we'll do x squared minus 4. Now, because I'm dividing, I am going to factor and divide out common factors. Similarly, you would not leave a fraction 2/4 as your final answer because I can divide out a 2 from the numerator and the denominator. I want to see if there's any common factors I can divide out. Factoring the top. Factoring the bottom. Good thing we checked. I can divide out an x plus 2. Note, I cannot divide out the x's here. Those are common terms, not common factors. So I can write now the domain. So it's going to be the domain f of x, domain g of x, intersecting where g of x cannot equal 0. Now again, we know f and g of x is negative infinity to positive infinity. Now, in the original problem, g of x is on the bottom, that's x squared minus 4. Well, we know that x cannot equal 2 and negative 2. So I'll write this in interval notation. So now that's telling me I cannot include 2 and I cannot include negative 2. So my final domain for this is all real numbers except, again, negative 2 and positive 2. All right, let's go to part D then. Now I have h minus j of x. So again, I'm going to separate and have it be h of x minus j of x. Well, we know h of x is square root of 1 minus 2x minus j of x. I'll do it in a different color. That's 1 over x. Now, this problem is rather bland. I'm going to rewrite it as one fraction, meaning I need to have an LCD, and the LCD is x. I'll make that note here. So that's the same thing as this. Now, I did not pick that problem for the subtraction. I picked this problem because of its domain. Okay, so let's write the domain then. So that's going to be the domain of h of x intersecting j of x, domain of j of x. Okay. Now, h of x. Well, we know h of x is 1 minus 2x underneath the square root. Meaning, because the index is even, that's got to be greater than or equal to 0. I can square both sides. Subtract the 1. And remember, because I'm dividing by a negative, I must switch the inequality sign. Okay. So, we know in interval notation, as I scroll down a little bit so I can show this, we know that's going to be negative infinity to 1/2. So I'll put that here. Now, j of x is 1 divided by x. We know here that x cannot equal 0. So that's easy to write in interval notation. I'll do that above. Now, remember, I now need the intersection of these two sets. So the best way for me to demonstrate this is to graph both of these on a number line. Let's do, first of all, in blue, negative infinity to 1/2. So here's 1/2 in shade. Now in red, I'm going to do all real numbers except 0. Now we know 0 is to the left of 1/2. Now remember, intersection, it's got to be in both the red and the blue. So it's very easy to tell at the beginning from the left-hand side, they both go to negative infinity. Included, 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 not 0. So we know part of this domain is going to go from negative infinity to 0, but I cannot include 0 because it's not in the red. Now, where else do they intersect? Here, here, and stops at 1/2. So, union 0 to 1/2. Because 1/2 is in both, I can put a bracket. But I cannot go any farther to the right because nothing else is shaded in the blue region. So my domain of h minus j of x is this. If you're not sure what the domain is going to be, graph both the solution sets on a number line and see where they intersect, because it's the intersection of these two domains. Okay, now what I would like to do is to plug in actual numbers for this. So when I plug in a number, I would expect to have some sort of number coming out. So let's take a look at g minus f of 3. Again, all I'm going to do is rewrite it as g of 3 minus f of 3. Now, g of 3 I'm going to do on the side. Now, plug in, that's 3 squared minus 4. Well, we know 3 squared is 9, minus 4 is 5. So g of 3 is 5. Let's do f of 3. Plug in, that is 3 squared plus 6 times 3 plus 8. That's 9 plus 18 plus 8. That is going to be 35. So f of 3 is 35. So we know 5 minus 35 is negative 30. Now, I could write this as an ordered pair. That's the domain at the very beginning. And that negative 30 is the range after I perform the operation in between the two functions. Okay, let's skip down to part f then. I want to do h divided by g of negative 4. I'm going to rewrite this. That is h of negative 4 divided by g of negative 4. Let's do h of negative 4 on the side. Plugging in. Well, negative 2 times negative 4 is 8. 1 plus 8, that's 9. And the square root of 9 is 3. Okay, scroll down a little bit, so I got a little bit of room for g of negative 4. Plug in. 16 minus 4, that's 12. So we now know that h of negative 4 is 3, and we know g of negative 4, g of negative 4 is 12, and that's 1/4. So now I could write this as an ordered pair. Again, that's the domain, negative 4 at the very beginning of this problem, and the range value of 1/4 after I perform the operation, which in this case is to divide the two functions.